Your brainwaves are contagious, and in the right room, with the right people, they synchronize like clocks on the same wall. A phenomenon physicists documented 3 centuries before anyone thought to measure a meditating brain. That synchronization does something measurable to the people in the room, and possibly to people who aren't. The research is stranger than you'd expect, and some of it comes from places you'd never associate with meditation. By the end of this, you'll understand a mechanism most practitioners feel but can't explain, and why meditating alone might be leaving the most potent effect on the table. In 1665, the Dutch physicist Christian Huygens noticed something odd about the pendulum clocks in his workshop. 2 clocks mounted on the same wooden beam would gradually fall into sync. Their pendulums swung in perfect opposition, tick for tick, without anyone adjusting them. He called it an odd kind of sympathy. The beam was transmitting vibrations between them, and the system naturally settled into coherence. Physicists now call this entrainment. It happens everywhere. Metronomes on a shared surface, fireflies along a riverbank flashing in unison, cardiac cells in a dish pulsing together before they're even wired into a heart. Your brain is a biological oscillator. It pulses at measurable frequencies, and when you sit in a room with other biological oscillators, the same physics applies. EEG studies on group meditators show something Huygens would have recognized instantly. When experienced practitioners meditate together, their brainwave patterns begin to converge. The frequency, the amplitude, even the phase of the oscillations start matching across individuals. This is called inter-brain synchrony, and it goes beyond what shared breathing or sitting in the same quiet room would produce. Researchers at the University of Freiburg measured pairs of meditators and found significant coherence in the alpha and gamma bands, the ranges associated with calm awareness and focused attention. Pairs who meditated alone in separate rooms showed no such convergence. Proximity mattered. The shared field mattered. So what's carrying the signal between brains? That part gets genuinely weird. One candidate is the electromagnetic field each brain produces. It's weak, about 1/1000th of Earth's magnetic field, barely detectable with the most sensitive equipment. Yet several research teams have proposed that when dozens of brains oscillate at the same frequency in close proximity, the overlapping fields may create a local electromagnetic environment that reinforces the shared rhythm. Think of it like sound waves. One tuning fork is quiet, 30 tuning forks vibrating at the same pitch fill the room. A team at the HeartMath Institute took this further. They measured heart rate variability, a marker of coherence between heart and brain, in groups practicing synchronized intention. When the group hit a threshold of internal coherence, individual members who'd been struggling to regulate their own rhythms suddenly locked in. The group acted like a carrier wave. Individuals who couldn't reach coherent states alone were pulled there by the collective signal. That's entrainment applied to human physiology. Huygens' clocks, 300 years later, made of tissue and intention. The implications get more uncomfortable from here, because some researchers decided to test whether this effect reaches beyond the room. The Global Consciousness Project, housed at Princeton for over a decade, maintained a network of random number generators scattered across dozens of countries. These devices produce continuous streams of ones and zeros, perfectly random by design. The project tracked whether global events correlated with statistical deviations from randomness. Large-scale meditation events were among the clearest signals. When thousands of people meditated simultaneously during organized events, the random number generators showed small but statistically significant shifts toward order. The effect sizes were tiny. The consistency across hundreds of trials was what caught attention. Roger Nelson, who ran the project, was careful with his language. He described the data as suggestive of a field-like consciousness effect and invited replication rather than drawing hard conclusions. Fair enough, the mechanism is unknown. The data pattern is real. Critics point to file draw effects and post-hoc analysis, and those concerns deserve weight. When you run enough statistical tests, some will hit significance by chance. The Princeton team published their methodology for peer review and released all raw data. The debate continues, and honest skepticism here is healthy science. Still, the pattern across hundreds of events spanning years is harder to dismiss as noise than any single data point would be. Meanwhile, a completely separate line of research was producing results that didn't require any exotic physics to explain. In 1993, a study in Washington, D.C. gathered 4,000 meditators over 2 months during the summer. Their prediction, registered in advance with the D.C. Police Department and an independent review board, was specific: violent crime would drop. The actual reduction during the peak meditation period reached roughly 23% based on FBI Uniform Crime Report data. Temperature, daylight hours, police staffing, and historical crime trends were controlled for. The principal investigator, John Hagelin, was a Harvard-trained quantum physicist. The study was published in a peer-reviewed criminology journal. One study proves nothing. The experimental design has been debated for decades. But the prediction was made in advance, the measurement was independent, and the result matched the hypothesis. That combination, whatever you think of the mechanism, is unusual. So what's actually happening at the level of the individual brain when group meditation works? Gamma wave synchrony offers one handle. Gamma oscillations, cycling around 40 times per second, are linked to moments of binding. When disparate brain regions suddenly collaborate on a single coherent percept or thought. Experienced meditators show elevated gamma activity solo. In group settings, the amplitude climbs higher, the coherence between left and right hemispheres increases. One proposed explanation is that the shared intention acts as an external pacemaker, giving each brain a signal to lock onto. Like musicians following the same conductor, the individual performance tightens when there's a shared reference beat. There's a social neuroscience angle too. Humans are wired for co-regulation. An infant's heart rate syncs to its mother's. Your breathing pattern shifts to match someone you're in deep conversation with. You felt this, sitting across from someone who's genuinely calm and feeling your own shoulders drop without deciding to relax them. Group meditation exploits this wiring deliberately. The collective calm becomes a signal your body reads as safety, and in that state of perceived safety, the brain allocates resources differently. Vigilance decreases. The regions involved in self-referential thinking quiet down. Attention becomes available for direction. Intention in this context stops being a vague spiritual concept and becomes something more like a tuning instruction. When you hold a specific thought or visualization during meditation, you're biasing your brain's processing toward particular patterns. When 100 people hold the same intention simultaneously, each brain reinforcing the shared frequency, the signal-to-noise ratio shifts. Each person's internal chatter has less pull against the collective coherence. The group becomes a signal amplifier. This maps neatly onto something engineers call constructive interference. When two waves of the same frequency align in phase, their amplitudes add together. The combined wave is stronger than either wave alone. Destructive interference, waves out of phase, cancels the signal. A room full of meditators holding incoherent scattered intentions would cancel each other out. A room holding one synchronized intention produces a combined amplitude that scales with participation. You've experienced a crude version of this at a concert. Thousands of people locked into the same rhythm, the same emotional frequency. The energy in that room is qualitatively different from listening to the same song alone in your headphones. Your skin prickles. Your chest opens. Something shifts in the body that the audio signal alone doesn't account for. Group meditation is that same mechanism, stripped of entertainment and pointed at a specific target. The practical upshot cuts against the lone wolf model of meditation that dominates Western practice. Apps, headphones, closed doors, solo cushions, all useful or limited by the physics. A single oscillator can only cohere with itself. It takes a network of oscillators to produce a field effect. Monasteries understood this centuries before EEG machines existed. So did indigenous ceremonial traditions, gospel churches, Sufi circles, and Quaker meetings. The forms vary enormously. The underlying mechanism, synchronized brains producing a coherent field that feeds back into each participant, appears to be universal. The question that keeps researchers honest is whether the effect extends beyond the room, the DC. Study in the Princeton data suggest it might. The skeptics' rebuttals are substantive. The mechanism for non-local effects remains theoretical, and yet the local effects, measurable brain synchrony, enhanced coherence, improved self-regulation in individuals who couldn't achieve it alone, stand on solid ground. You probably meditate alone. Most people do. And that practice builds the internal coherence that makes group synchrony possible in the first place. Solo practice is the instrument. Group practice is the orchestra. One trains the oscillator. The other reveals what oscillators can do when they stop vibrating in isolation. Huygens never meditated. He just watched two clocks on a beam and noticed they couldn't help falling into rhythm. 300 years of physics later, the principle holds. Put coherent systems in proximity and they synchronize. The only variable that's changed is that now the clocks are aware they're ticking.